Hello, my name is Aaron, and this is 7th grade, lesson 27. For our first problem, Darchelle works as a babysitter. She earns $S monthly. Next month, her monthly salary will be increased by 12%. The expression 1.12S represents her future salary, which expression also represents her future salary. If you remember the problems from last week's worksheet, this is very similar, just working in reverse. Previously, we had combined and simplified, so if we had something that looked like x plus 0.12x, we would have simplified to 1.12x because the coefficients of terms with the same base, when added together, are also added together, and there's an invisible 1 here. Working in reverse, 1.12s. I kind of spoiled the answer here, but we're going to be breaking it up into two terms that each have an s, because note, the important part is they have to have the same variable in order to add or be broken up. So we keep our s. Now, if you look at the answer choices, all of them have an s. So we'll be leaving this alone, except for one minor detail. I'm going to be adding the invisible 1, just like before, just to help us keep track of the coefficients. Now, in order to solve for this blank here, the mystery coefficient, we're going to work in the reverse. Instead of adding the parts to get the final sum, we're going to be subtracting 1 from 1.12. Of course, let me write this correctly, like this, with placeholder zeros. This is, of course, 0.12. We fill in the blank, and then that is b. 2 are problems that we've done before, where we're given some sort of sentence and we have to turn it into a variable and a coefficient. In this case, k is decreased by 26%. So it got 26% smaller. Or in other words, we subtracted 26% from how much did we have originally? 100%, or 1. And we had to add the k's because we're subtracting 26% k. If you think about it that way, we're not just subtracting 26% x or a random number. It's k. K is shrinking. If we do the math, this is 0.74k. The k stays. And with that in mind, the answer is a B. There are T 6 packs of soda and B 4 packs of juice. Expression 6T plus 4V represents the total number of bottled drinks, which expression also represents the total number of bottled drinks. Now in this one, we're going to be basically factoring out a common factor and writing something so it looks like this. T plus blank V, where we factor out a constant over here. If you note, both 6 and 4 are even, which means we can factor out a 2. So if we do that, 6 divided by 2 is 3, 4 divided by 2 is 2. Let's check to see if this answer is here, and it is in fact here. So that is the correct answer. An alternative way to do it is to use prime factorization on both 6 and 4. 6 is 2 and 3. 4 is 2 and 2. They share a 2, which means we can factor it out, as shown like this. However, then we're left with the 3 and 2, as represented by our coefficients, and these do not share any common prime factors. So we are done. Cindy's dog weighed T pounds before she started a new diet. Then she lost 15% of her weight. I'm guessing she is the dog. The expression T minus 15% T represents Cindy's dog's new weight, which expression also represents a new weight. This is just like problems that we've done before, so I'll let you do it on your own. Same with 5 and 6. Now, evaluate the expression. Calculators allowed and they want exact answers. That is a peculiar way to word it. I believe they mean decimal answers. So, with that in mind, let's look at this problem. Actually, I'll stick with what they're asking for here. I'm not sure if they want decimal answers, because they did say calculators allowed, but that might just be to solve for these exponents really quickly. An exact answer means we're going to leave it in a fractional form, because for decimals, we're going to have to round off at some point, right? Like let's say 1 over 3 in decimal form is 0.3333 and forever. So we're going to have to stop writing these numbers at a point, because we can't just fill the entire page with 3's, which means this is not quite 1/3. It's not exact. So this is the exact answer. This is a decimal answer. With that in mind, let's leave it as a fraction. 4 to the power of -3. When you have a negative exponent, the way this works is you're going to put it from the numerator to the denominator or vice versa. Basically, it goes to the opposite side of the fraction. Now you might be wondering, but where's the fraction? I don't see a fraction or a numerator or denominator here. If you remember, all whole numbers are actually a fraction as well, the denominator being 1. With that in mind, the -3 on the exponent means we're going to have to move this to the denominator. So it'll turn into 1, because there's nothing left, just a 1. Don't put 0, it is not 0. Over 4 to the third, 4 cubed. Now that we've moved it, the exponent is no longer negative. And then you can use a calculator to solve for this, but I know that 4 cubed is 64. And this would be our final exact answer. The same thing for 2, where we move it to the bottom and cube it. Use a calculator. 7 cubed is a nasty number. Now, for 3, -3 to the power of -1 works just as you would think. Just because it's negative doesn't mean anything changes. We move it to the bottom, the entire thing thought, because it's in parentheses, right? To the power of 1, and something to the power of 1 is just itself. It doesn't change. So it's 1 over -3. Or you can write it as -1/3. These are the exact same. Same with number 4. 5 is going over a different exponent rule. When you have an exponent of 0, x to the power of 0 is equal to 1. This is true for any number, any value of x. So 2 to the power of 0 is equal to 1. -4 to the power of 0 is equal to 1. 3/4 to the power of 0 is also equal to 1. If I have 1, 6, 9, 4, 3, 6 to the power of 0, it would equal 1. Now, fractions to a negative exponent. This is a little bit tricky, but we just need to think about it like before. We're flipping. If you remember, we just need to combine our two rules. X to the power of -1 is equal to 1 over x. And another rule is that if you have a fraction to the power of a exponent, we can distribute the exponent to top and bottom, the numerator and denominator. Combining this, we get something that looks like this. 2 to the power of -2, 7 to the power of -2. We move them to the other side because of our negative exponent rule, which means we have 7 squared on top and 2 squared on the bottom. If you calculate that, that is 49 over 4, which does not simplify. Now, you might be noticing something. Wait a second. 7 over 2 is just the reciprocal of 2 over 7. And that's exactly true. When you combine these two rules, you get that a fraction, the entire fraction, to a negative exponent means the reciprocal of that fraction to the positive version of the exponent. So let's try number 9. 4/3 to the power of -3 is the reciprocal 3 over 4 to the power of the positive version, just cubed. Then we cube top and bottom to get 27 over 64. I'm not sure if that simplifies. You can use a calculator to check. I'll just be moving on. Next, we have some nastier problems. 0 as a base to the power of -3. Let's use what we know about negative exponents. 0 to the power of -3, well, that's technically 0 to the power of 1. So if we do that, we would move it to the bottom. And, oh wait, 0 cubed is just 0, which means we have 1 over 0. And if you know, a fraction cannot have 0 as a denominator. It doesn't work. So the correct answer is undefined. 0 to the power of -3 is undefined. Same thing with 0 to the power of -2. And then for our final set, we'll be using another exponent rule, which is what happens when you multiply two things together that both have exponents. Well, if they have the same base, and if you remember, base is the number right here, so in this case our base of 2, both of them have the same base of 2, then the answer is, when they're multiplied, b plus c. With that in mind, the base stays the same, and then this is -2 plus -3, which is just -3, which is -2 to the power of -5, which is, oops, not -2. That's my mistake. +2 to the power of -5. Then 1 over 2 to the 5, which is 1 over 32. That's the correct answer for 12. Now I'll leave the rest to you. Just use all the exponent rules we've covered, and you'll be able to solve them. Thank you.